All right, guys, so before we get started on today's lesson, are there any questions over the homework assignments? Any questions over the homework?
All right, shut up.
How's it going?
What hour do you have open? I was going to come talk to you about next semester. Third hour? Third hour planning period?
Yep.
Okay, maybe I can get you.
Sounds good.
Be glad if I make it through this.
All right, guys, so questions on the homework before we get started. So what we're starting today in section 4.5 and 4.6, we're skipping 4.4, is solving. We're going to start solving these higher degree polynomial functions. And so far, the ways that we know to solve or be able to solve polynomials is one of four: factoring, graphing, quadratic formula, and completing the square. These are the four main methods we have for solving polynomial functions. And quadratic formula and completing the square specifically work on quadratics. Specifically work on quadratic or quadratic types. And really, they're mainly quadratic, so they're going to be degree 2. So we're not going to be able to use quadratic formula on our cubics, quartics, degree 3, 4, 5, 6. But if we can get them down to a degree 2, if we can take it from a cubic down to a quadratic, if we can get them back to quadratics, then we can use quadratic formula or completing the square on them to find those solutions. Factoring and graphing work for any higher degree polynomial function. It is possible to factor these higher degree polynomial functions, and it's definitely possible to graph. We won't be doing a whole lot of the factoring, mainly just time's sake. That's what mainly 4.4 was focusing on, was factoring by grouping and our perfects, difference in sum of perfect cubes factoring. So we're going to mainly be focused on especially graphing, quadratic formula, and some other methods we're going to go over with solving higher degree polynomial functions. And the graphing calculator is going to be key and especially helpful in solving. So when we look at a problem like this here, 2x cubed minus 12x squared plus 18x equals 0. Now, the tools that we have so far with factoring, we can actually use to solve this here. Because if we're going to factor this, the first thing we look at and look to see if it has is a greatest common factor. We see if something's in common with all the terms, and we can start that because it is equal to 0. So we look at all three of these terms here and see if there's a number or variable in common with all three. And as we look at this here, 2, 12, and 18 all have a common factor of 2 that we can factor out. But they also have a greatest common factor of x that we can factor out. Because I can factor 2x out of 2x cubed. The 2 factors out completely, and factoring out the x reduces it from x cubed to x squared. The sign's still going to stay the same because we didn't factor a negative out. But when we factor 2 out of 12, 12 divided by 2 is 6. And when I factor an x out of x squared, we're left with x. Plus, we can factor a 2x out of 18x. When we factor the 2 out of 18, we divide 18 by 2, we get 9. And the x factors out completely. So by being able to factor out the 2x, this gives us something we know how to factor. Because 2x cubed minus 12x squared plus 18x, we don't have a way to factor it. But when we pulled that greatest common factor of 2x out, it gave us a quadratic. And we factored quadratics before. We know how to factor a quadratic expression. And the first step in factoring a quadratic expression is our 2 sets of parentheses with 3 spaces. And once we have this set up, we're going to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is positive, so the signs are going to be the same and match the sign of the middle term, which is negative. So we'll have negative and negative. That moves us on to our next step, the factors of the first and third terms. So factors of x squared, we don't write it out because there's only one set, and it's x and x. Factors of the first term go in the first space in both of those parentheses. Factors of the third term, we're looking at the factors of 9, which is 1 and 9 or 3 and 3. This point here, we can try 3 and 3. And then the last thing we need to do is to check and make sure we got the correct factors. Now, we don't multiply the first and first. We're not going to multiply x and x because x times x is x squared, and we got that from the factors of x squared. We're not going to multiply our 3 and 3 because those are indeed the factors of 9, so they're going to multiply back together to give us 9. The one we want to check for is the middle term, this negative 6x. Now, x times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3x minus 3x, negative 3 minus 3 is negative 6x, which is indeed the middle term that we wanted. So it's telling us these are the correct factors. Questions on this so far? Now, when we have two or more things multiplied together, one of them has to be 0. And we actually have three things being multiplied together. We have 2x, x minus 3, and x minus 3. So each one of these could be equal to 0. And we can solve our 2x equals 0 first. So the first thing we can do is divide both sides by 2. And 2x divided by 2 is going to be just x. And 0 divided by 2 is 0. So one of our solutions for this here is that x is equal to 0. Now we can move on to our x minus 3 is equal to 0, so we do need to get x by itself. We add 3 to both sides, telling us x is equal to 3. And we can do the exact same thing to the other x minus 3, telling us x is equal to 3. So for this here, x is equal to 3, x is equal to 3, and x is equal to 0. We have three solutions. Questions on this here? All right, let's look at the next one. 5x cubed minus 40x squared plus 80x equals 0. Now, I kind of skipped over and came back to it, but we do need to make sure that the equation is equal to 0. We need all the terms on the same side. For any higher degree polynomial function, we really start off by getting that equation equal to 0 first. Now, at this point here, we're going to go on and factor, because 5x cubed, negative 40x squared, plus 80x all has a greatest common factor of 5x. Because 5, 40, and 80 all have a common factor of 5. X cubed, x squared, and x have a greatest common factor of x. Now, if we factor 5x out of 5x cubed, we're left with x squared. When we factor 5x out of 40, we're left with 8x, because 40 divided by 5 is 8, x squared divided by x is just x. Plus, 80 divided by 5 is going to be 16. And x divided by x simplifies out. Now we're going to go on and factor x squared minus 8x plus 16. So we'll have two sets of parentheses with three spaces. Now we need to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So here, since the third term is positive, our signs are the same and going to match the sign of the middle term. So we'll have negative and negative. Those signs will be the same. Now we need to find...
Students that come to the office, Caleb Blackbox, Ava Myers, Greg Williams, Brooklyn Williams, and Ray Walford.
Find the factors of the first and third term. So our factors of x squared are going to be x and x. Those are the only factors of x squared that we can have, so we go on and plug those in. Now 16, on the other hand, has several different factors. We have 1 and 16, 2 and 8, 3 is not 1, but we also have 4 and 4. Which set of factors do we want to try first? 4 and 4. And lastly, we just need to check and make sure these are the correct factors before we continue with solving. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4x minus 4x is negative 8x. So we do have the correct factors, which means we can use our zero product property and set these three expressions equal to 0. Because again, zero product property says that if we have two or more things multiplied together to equal 0, one of them has to be 0. Well, wait a minute, can't we use the zero product property on 5x equals 0? Because you have two or more things multiplied together equals 0. So one of those two has to be 0. So really, we could just say that here x is equal to 0. Or if we don't notice that, we can still just divide both sides by 5. 5x divided by 5 is x. 0 divided by 5 is still 0. So x equals 0. For our x minus 4, we can add 4 to both sides, telling us x is positive 4. Do the same thing for the other one, telling us x is 4. So x is equal to 0, x is equal to 4, and x is equal to 4. Questions on this here? Questions on any of this so far? So we could also have graphed this, because we have 5x cubed minus 40x squared plus 80x. And we graph this here. Because again, when we graph, we're looking for what values of x will make the function equal 0. And we see that we have 3 spots. We have one at the origin and one possibly at 4. So we can go second graph to look at the table. And we do see that when x is 0, the y value is 0. So that's a solution. We also see when x is 4, the y value is 0. Also, if you note this, that, well, it's only telling us that x is 0, or gives us a y value of 0 when x is 4. It only shows us it once. It doesn't show us that here, and especially in the table, that it's actually repeated. Now, there's an easy way for us to be able to tell, and that's based off the graph. Solutions for higher degree polynomial functions, have an even multiplicity if they touch the graph and don't cross it. All that means is at here, x equals 4 has an even multiplicity because, as we see the graph here, it touches the x-axis but does not cross it. So that tells me that the number of zeros at that spot is an even amount. So it could be 2, it could be 4, it could be 6, it could be 8. It's an even number. If it crosses the x-axis, it's an odd multiplicity. That means it can show up 1, 3, 5, 7, 9. It gives us a way to determine if there's more than 1 0 at that spot. Are you ready to look at the next one? Now, negative 2x to the fourth plus 16x squared minus 32 is factorable. There are ways to factor this, but unfortunately, just based off time constraints and the fact that we are this week and next week and we are done with the semester, I'm focusing more on actually solving than going through the factoring.
Are you going to try to finish chapter 4 by the end of the
Yep.
One more question.
Yes.
Before the semester is going on break, are we gonna have like a test?
Yes. Over chapter 4.
Okay.
You're going to have a chapter 4 test. So, if we want to find the zeros for this here, we can actually graph this. Negative 2x to the fourth plus 16x squared minus 32. X to the fourth minus 16. Be good if I had my own sheet so I'm not flipping back and forth. Now we have this here. Now we see that it touches the x-axis and does not cross it in two places. One of them's positive, one of them's negative. So if we look at the table, we see that two of those solutions are 2 and negative 2. Those are two of the solutions that we have. So we know that x is equal to 2 and x is equal to negative 2. We know those two are the solutions for sure. Now this is getting a little bit ahead and kind of like what we were going to talk about, especially it's going to show up more in 4.6, but that's fine. We have something called the fundamental theorem of algebra. Fundamental theorem of algebra states that for every polynomial function, there exists one solution in the complex plane, which is fine. But the bigger thing from it is that the number of solutions for any polynomial function is equal to the degree. Is equal to the degree of that polynomial equation. So since this is a degree 4, it means that we have 4 solutions. There are 4 values of x that will make this function equal 0. And if there's any repeated solutions, we count each repeated solution. So that means if we look back at the previous problem, the degree is 3, and we have 1, 2, 3 solutions. Even though 4 is repeated twice, we count both of them as individual solutions. So that means x is equal to 2 and x is equal to negative 2, but there's a good chance that 2 and negative 2 are repeated solutions. So we see them more than once. So really this is it here. And the way we can check this is we can use synthetic division to reduce it and see if it works more than once. Because if the remainder is 0, we know that if we evaluated x or f of x at that value, it would also be 0. And when the function is equal to 0, it is a solution. So if we wanted to check and see if this is a solution for 2 and negative 2, we can use synthetic division to get there. So we'll plug 2 as our solution in the cubby, and we'll put our numbers across the top. Negative 2 for x to the fourth, 0 for x cubed, 16 for x squared, 0 for x, and negative 32. Then we'll bring down the negative 2. And then we'll go through our synthetic division steps. So we'll say 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. 2 times negative 4 is negative 8. Yeah, 16 plus negative 8 is going to be positive 8. 2 times 8 is positive 16. 0 plus 16 is 16. And lastly, 2 times 16 is 32. And negative 32 plus 32 is indeed 0. So it shows us that that is a solution. But by doing the synthetic division, what we've done is taken that solution out. We've removed it from the solution set because we know it works, it's a solution. Now our negative 2, negative 4, 8, 16, that polynomial expression, I'm going to put the variables back in for a second. If we'd have x squared, x cubed, we have negative 2x cubed minus 4x squared plus 8x plus 16. This new one is the same equation except we removed one of those solutions from. We can kind of understand that. If we've divided that solution out, we've removed it out. So, if, use a different color, 2 was a solution twice. If 2 shows up as a solution twice, that means we can do the synthetic division again. If we can do it twice, it means it's a solution twice. Does that make sense? If it's a solution 3 times, we could do it 3 times each time going down. It also means that 2 isn't a solution again if the remainder is not 0. If the remainder is also 0 again, it means it's a solution again. So if we look at this here, 2 times negative 2 is negative 4. Negative 4 plus negative 4 is negative 8. 2 times negative 8 is negative 16. 8 plus negative 16 is negative 8. 2 times negative 8 is negative 16, and 16 plus negative 16 is indeed 0. So really what we've shown and verified that 2 is a solution twice. Yes? You don't have to write this. I wouldn't write this because I can easily erase. Because if I wanted to check and see if positive 2 showed up a third time, I could divide it, the result again, by 2. 2 times negative 2 is negative 4. And then negative 8 plus negative 4 would be negative 12. Two times negative 12 is negative 24. Negative 8 plus negative 24 is negative 32. Since the remainder is not 0, it means 2 is not a solution again to that problem. But we could do it with negative 2. Negative 2 times negative 2 would be positive 4. Negative 8 plus 4 is negative 4. Negative 2 times negative 4 is positive 8. And negative 8 plus 8 is 0. And really, this is kind of, it's ahead of where we're at, but that's fine. Because normally we would use factoring to factor this and solve it that way. But once we get these zeros, we can actually start solving and removing solutions. Let's see, let's go here. Because when we started this, the degree was 4, we had x to the 4th. We divided that solution out and it took it down to x to the 3rd. Because x to the 4th, x cubed, x squared, x cubed, x squared, x squared, x. Because each time we divided, we reduced the degree by 1. We took one of the solutions away. So our current problem, or the current equation that we have now.
May I have your attention? May I have your attention? There will be Bible study again today for the students in Miss Williams' class during lunchtime. Thank you.
That we have left with is negative 2x minus 4 equals 0. This is nice. This we can solve easily by adding 4 to both sides, telling us that negative 2x is equal to 4. Divide both sides by negative 2, telling us x is equal to negative 2. So really all we did there was just verify that the solution is 2, 2, negative 2, negative 2. Because once we get these solutions, we can reduce the degree. like I said at the start, the main two that we have that work every time is quadratic formula and completing square. So if we can get enough solutions to get it down to a degree 2, that's great. We have ways to solve it. If we can get it down to a degree 1, that's even better because it's just a linear equation. We can solve that very nicely. And the best case scenario is that we get every solution. Because if we get all of them, we're done. We don't have to do anything else. Questions on this here? Yes. X to the fourth minus 18x squared plus 81. Well, we can graph that. And we see that it intersects the x-axis at -3 and 3. And as we look at the graph, because it touches the x-axis and does not cross it, we can say those solutions subplane. And that's it. So it's -3, 3, -3, 3. And then we could go about doing synthetic division to make sure. But really, we found all three. 1, 0, -18, 0, 81. And we can bring the 1 down. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 would be 9. -18 plus 9 is -9. 3 times 9 is -27. 0 plus -27 is going to be -27. And lastly, 3 times -27 would be -81. And 81 plus -81 would indeed be 0. We can then try -3. -3 times 1 is -3. -3 plus 3 is 0. -3 times 0 is 0. -9 plus 0 is -9. -3 times -9 is +27, and -27 plus 27 is 0. Now at this point here, if we didn't know the other two solutions were possibly 3 and -3, we could actually just start solving here, because what we've got now is a quadratic. We have x squared plus 0x minus 9. Or it's just x squared minus 9. Now we can factor this here because it is a difference of perfect squares. Or we can use the square root method. Our square root method got the x squared term by itself. And then we took the square root of both sides. So we can get the x squared term by itself by adding 9 to both sides. Then taking the square root of both sides, because the square root of x squared is x. And the square root of 9 is 3. And whenever we take the square root of both sides, we have to put the plus or minus. So we're able to solve it using this here. Questions on any of this here? I'm going to skip this one. We're going to look at one more, 2x to the fifth. Let's see here. Yeah, plus 24x equals 14x cubed. So this one here, if we're going to solve this, we first, either graphing or factoring, we need to get this equation equal to 0. So the first thing we can do is subtract 14x cubed from both sides. And that tells us that we have 2x to the fifth minus 14x cubed plus 24x equal to 0. Because again, with solving any of these here, we need to make sure we get the equation equal to 0. Bless you. Then once we get it equal to 0, I would go on and graph it. Yes. To the third plus 24x. Now, looking at this here, we know that we should have 5 solutions. We should have 5 values of x that are going to make this equation equal to 0. And when we look at this by graphing, we want to find at least 2 less, so the degree minus 2 number of solutions. So if it's a degree 5, we need to find at least 3. Because if I can find 3 solutions, 3 values of x, that will make this function be 0, I can at least get it to a quadratic. If we can get it to a quadratic, we can solve from there. Now, if we look at this here, I do have -2, 0, and 2. So we can say the solutions are x is equal to 2, 0, -2. And we can write it out as x equals 2, comma 0, comma -2 with commas. Or we could write it out as x equals 2, x equals 0, x equals -2. And now that we have these, we can use synthetic division to reduce the degree of this polynomial from 5 to 4, 4 to 3, and then 3 to 2, and solve what is left over. And we put one of the first solutions into the cubby. So we can put 2. And we put our coefficients of the equation that we have across the top. So 2 for x to the 5th, 0 for x to the 4th, -14 for x cubed, 0 for x squared, 24 for x, and then 0 for our constant term. Since the degree is 5, we should have one more than that of numbers across the top. So we should have 6, 2 for x to the 5th, 0 for x to the 4th, -14 for x cubed, 0 for x squared, 24 for x, and then 0 for our constant term. And now we're going to go through our synthetic division steps to find and reduce this here. Now, 2 times 2 is going to give us 4. 0 plus 4 is 4. 2 times 4 is 8. -14 plus 8 is -6. 2 times -6 is -12. 0 plus -12 is -12. 2 times -12 is -24. 24 plus -24 is 0. 2 times 0 is 0, and 0 plus 0 is 0. And again, when we're solving, we're plugging in these solutions, we should get a remainder of 0. Because it is a solution, it should make the value of the function be 0. And according to our remainder theorem, it should make the equation equal 0. And with most of these here, I just go on and do the next synthetic division off that bottom line. Some will rewrite it. I think it's easier just to keep going on the line. Do we want to do -2 or 0 next? Doesn't really matter. We can do 0. Because 0 is a solution. Now 0 times 2 is 0. 4 plus 0 is 4. 0 times 4 is 0. -6 plus 0 is -6. 0 times -6 is 0. -12 plus 0 is -12. 0 times -12 is 0. And 0 plus 0 is 0. So it worked out. And the last value that we found was -2. -2 times 2 is -4. 4 plus -4 is 0. -2 times 0 is 0. -6 plus 0 is -6. -2 times -6 is +12. And -12 plus 12 is 0. So all we've done is really, we've confirmed that 2, 0, and -2 are solutions, but we've also decreased the degree of this polynomial from a degree 5 down to a degree 2. And we plug the variables back in. The 0 in the box is the remainder. Our -6 is our constant term, our term without x. 0 is the term with x, and 2 is the term with x squared. telling us that the current equation that we have left to finish solving is 2x squared minus 6 equals 0. Now we could try factoring, but this is not going to factor because it would have to be a difference of perfect squares. 6 is not a perfect square. 2x squared is not a perfect square. So luckily we do have the square root method. Square root method works if we have just the x squared term. We do not have an x to the first term. We have a squared term, or the only variable shows up inside a set of parentheses squared. And the reason this is nice, since we don't have an x term, we can move everything to the other side except for x squared. So we can add 6 to both sides, telling us that 2x squared equals 6. Since x squared is still not by itself, we can divide both sides by 2, telling us x squared is equal to 3. And since x squared is now by itself, we would square root both sides. Square root of x squared is x. Those cancel. And the square root of 3 is the square root of 3. But as always, when we take the square root of both sides, we have to add the plus or minus. So it's telling us our last two solutions are positive and negative square root of 3. And that would be all 5 solutions, because 2, 0, negative 2, square root of 3, negative square root of 3 are 5 solutions. So those are all 5 solutions for this here. Questions on any of this here? Now, graphing is going to be one of the biggest ways for us to be able to solve these. But the question is, what's going to happen when the graph or the solutions are not nice integer answers? Because we've seen rational solutions come up time and time again. And for the most part, we really haven't, graphing doesn't work well. We have to figure out or estimate and figure those out. But there is a theorem called the rational root theorem. The rational root theorem is going to help us find those rational solutions that could possibly work, and we're going to use it with graphing, using it with the graphing calculator, because combined, they're really going to help us figure out these solutions. And the rational root theorem states for any polynomial function, that's what the a sub n, x to the n plus dot 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 a sub 1 times x plus a sub 0. Any polynomial function that we could possibly have is going to have integer coefficients that every rational solution of the function of f of x equals 0 has the following form: plus or minus p over q, where p is the factors of the constant term and q is the factors of the leading coefficient. So doing this here, this plus or minus p over q will give us every possible rational 0 that it could have. Let's focus in. And if it is a rational 0, it will be listed here. It does not mean every solution or every number we get from this here is a solution. But if a solution is a rational solution, it will tell us what it is. It will be contained in the list. So one of the first things we have to do is we have to get the equation equal to 0. Here it is. And we want to find our plus or minus p over q, where p is the factors of the constant term and q is the factors of the leading coefficient. So our leading coefficient, the number in front of our variable with the biggest exponent, in this case is 1. So the factors of 1 is just 1. Now we also have to find the factors of the constant term, our number without a variable. So we need to find the factors of 20. And one of the set of factors at 20 is 1 and 20. We also have 2 and 10, 4 and 5. So I like to list them out here so that we have them all written out. So the factors of p are 1, 2, 4, 5, 10, and 20. Questions on this so far? Now, to find all the rational zeros, we take every value of p and divide it by every value of q. And I always start with q, so I pick 1 first. So we're going to have plus or minus 1 divided by 1. And we could write it out as 1 divided by 1. But what is 1 divided by 1? It's just 1. Comma. Then we're going to do 2 divided by 1, which is 2. Then we're going to do 4 divided by 1, which is 4. 5 divided by 1 is 5. 10 divided by 1, 10, and 20 divided by 1, 20. And it is positive or negative, so we have that plus or minus. So the rational solutions for this here, the rational values that we could have for this, not quite, we got 2 minutes. So all the rational zeros that we could have, if the solutions for this are rational, it's either positive negative 1, positive negative 2, positive negative 4, positive negative 5, positive negative 10, or positive negative or 20. So those could be the rational solutions, but there are only 3 solutions that work. So only 3 of these values could work for this here. We will finish this problem tomorrow.